Okay, so here it's a cantilever beam, and that cantilever beam is fixed here and the free on the other side. And I want to apply on this cantilever beam. It has a size 100 by 200 size, and the length is about 1000 millimeter. And I have a load of 15 kilonewton meter square on the top surface of the beam. Elastic modulus is 70 gigapascal, which is 70,000 newton millimeter square. Poisson ratio is 0.3. I need to model this using beam element, 2D plane strain, and 3D element. Or 2D plane stress, indeed. So, let's do it with plane strain at the moment because we have another example with plane stress. Let's do plane strain. Is usually plane strain, we usually, if that is a big size, for example, this could be 1,000. Yeah, you can make it as a B plane strain. But usually this case, thin is not too thin, so it should be plane stress. But for the sake of exercise, for this case, should be stress. For the sake of exercise, we're going to use a strain element, plane strain element. So plane strain, if that is big size, but it's like 1,000 or 10,000 millimeters, it's quite big in the other direction, in the dimension. But because we, just for the sake of exercise, so then we could only work out just to exercise. Anyway, now I want to use a 3D element. So let's look at different options and see how to model in Abacus. So I need to model firstly a beam element. So to model a beam element is just basically a beam in the length of 1,000 millimeter length and fix on that point and has a distributed load on the top. Simple beam. Let's go to Abacus. CIE. You go standard, and then you go to file, then you save as, you go where do you want to save the model at. So I want to save it somewhere here, Abacus. So I need, for example, let's call it a beam element. Okay. You click here, beam element, then okay. And then we do a set directory. You go to models, set directory. Again, you click on this. You need to set directory to save the place, the model somewhere. Click here, and then set directory Abacus, and just click on here, beam element. Okay. Now it's simply you need how to create the beam element. You click on the part, and you call it beam. Go to the planar and then wire. So because it's a linear. So be careful. Something here is the dimension will be a line element, but it's 1,000 millimeters. So how are you gonna draw a beam on a size of 200 size beige? So it lists to have to be more than 1,000. Let's say 1,500 beige size. So to draw that 1,000 millimeter beam, then it said to continue. So maybe even bigger. Tell you why. So let's say 3,000 double. I'll tell you why. 3,500. Let's say double of the length, more than double of the length. Let's tell you why. Because you need to draw, assume the coordinate system in here, and then you have x and y. Yeah, you see here. So it's 1,000. So let's show you. So make it big enough. Then you go to a wire element or line element. You click here, coordinate system 0, 0. And then you need to have a length of 1,000, 0. So 1,000, 0. It's 8,000 and then 0. You see? That's why we need to big size, quite big size. Then okay, click here and then you set done. It's got your beam element. Save it. You go to property. You click here, create section, and you go to elasticity, call it steel, for example. You click here, elastic, and it's 70,000 Newton millimeter square and 0.3 Poisson ratio. Indeed, it's not steel, it's aluminium. Okay. You click OK. Now you click here. You click create. It's a beam element, so not Ross, it's a beam element. So go click beam and then you continue. And to ask you what is the type of section profile, you click on the section profile and tell him I want it to be a rectangular section. You could continue. The height, which is 100, and the height is around 200, I think. Yeah, 100 by 200, 100 by 200. Yeah. So okay, and everything else should be okay, and then done. You go then to section manager. You click create. You click on the beam, then done, and you choose the section that you created, which is okay, the beam type. Now you go to property, it's still here. So, and my suggestion for property, you go into tool. I think you need to do kind of, yeah, beam orientation. Go to assign beam orientation. You click on the beam, then done, then enter, and then enter. So you could recreate the orientation needed for the beam. You go now to assembly, you bring the beam. So you go to assembly instance and make it independent measures, and okay. You go to step, also create a step, create, and the general static you use, then you continue and assume this is geometric nonlinear is included, and the load is 0.1, initial load as we suggested, and then you said okay. Then you go to loading, so you need to fix boundary condition. You click in here, you click create, go to initial, and then my suggestion here encasted. So you click, you could click on this, then continue. You click on the point here, and then done, and you encast it. It's basically it's fixed all the way. If you have a fix here, you need to choose this point and the other point. But now you have only one point. To choose multiple points, you need to press shift. So you only have fix on the start. Okay, done. Then you need to apply a load. You create, you go to step. Let's see how we can apply the load. If we do line load, let's try the line load and then continue. Should be working now. And click on the line load and then done. But how much this line load? Now be careful about this line load. It's basically you have 15 kilonewton per meter square. So 15 kilonewton per meter square. Now you need to multiply by the thickness. So basically it's 15 kilonewton per meter square multiplied by the thickness here to have it distributed in the other direction. So which is about 0.1 meter because it's all meter, 0.1, and that is in the, so it's 15 times 0 is 1.5 kilonewton per meter. That's kilonewton per meter. But Newton to per millimeter, you need to do 1.5 times 1000, 1.5 times 1000 to be in Newton, and then divided by from meter to millimeter 1000. So basically, this is going to become a Newton, and this is become millimeter, and that is 1.5 Newton per millimeter. Okay, so if you struggle with that, actually, you can just Google it and say, you can say, for example, you can say what you can say, convert from Newton per millimeter to, sorry, kilonewton per millimeter, kilonewton per meter to Newton per millimeter, if you really want it. So basically, it's 1 kilonewton meter, it's 1 Newton millimeter. Or you click here if you want, and that's simply, it's 1.5, and convert is 1.5. Yeah, it's the same. Okay. So basically, I multiply by that thickness to make it Newton, kilonewton meter in the other direction. So you have 1.5 Newton per millimeter. So you click there here. So in that component in 0, there's no in x direction, but you have a component in the y direction, which is basically Newton. It's which 1.5. In y direction, it should be minus because it's opposite direction of y. Then, okay, here we go. We apply the load, distributed load. If you want to try a pressure, let's see how we'll try a pressure. I don't think gonna work. Maybe it work. I don't know. If you apply a pressure, you still also apply a pressure, but I don't recommend to you to apply a pressure. I think like line load it should be. Anyway. And then let's see anyway, try it, and then you go to mesh, you click on the mesh here and apply, and it's quite not too big, so you change it maybe to 25 millimeter, apply a mesh, and then okay, you click here and then yes, so you apply a mesh. Now you need to define the type of the elements. You click here, you click in the element, and then you say done. You need a beam and linear. It's a linear beam in plane. So that is a type of element, B21. And you said okay, it should be beam. Then here we go, and then you go job, create, and then okay, and then okay, and then submit. Let's see how it goes. Let's see the deflection, how much the deflection. Not completed, so let's go results. Click here. So you can see the stresses. And let's see the deflection. You go into U and the deflection in Y direction. And you click here. Click in the node value and you click on the deflection node. It's a quite small deflection. It's about 0.04 millimeters, very small. So let's see 0.04 millimeter. It's very small because the load is applied is too small. You can change the load if you want. So 0.04 millimeter. Remember this. Okay, that's done. Now, if you wanted to do it a 2D plane strain, that's what you can do is you can go to the same model. So you go right click and create a new model, model 2, and then okay. So ensure you have double click on this. So to create model. So what you need to create again, model which has a size of 100,000 by 200, and then you create apply load. Let's try it. So you click here, go to part, and it's 2D planar, shell, and then you continue. Again, make it a bit big, this one, again, as we said. You continue. You go to the rectangle. That time you need the rectangle to be in one point is 0, 0, and the other point is 1000 by 200. So it's 0, 0, and then 1000 by 200. Then okay, and then you don't. You have to create a beam. And then you go to property, create. You go to material, and elasticity is 70,000 megapascal and 0.3. And then you go to assembly, click the assembly, independent, and then OK. Now you go to step, create step as normal, general static, and 0.1 initial. I want to try something now, and I want to try something here. So then go to load. Before load, you go to mesh. Click here, make the mesh also again 25, apply, then OK. Then you mesh it. There you go. And ensure you create on a type of element. You click with a plane stress. So you want a plane strain. And don't use disintegration. Okay? You cannot use a plane stress. I will use a plane strain and not a true disintegration. Okay. And then let's go to load. You go to fixed boundary condition. You click create, and then you click on initial, and you click on that, and continue, and click on the edge because of fixed, and continue, and then encasted, fixed all the way here, fixed. And okay, so fixes all use and rotations are constraints. So then okay. Now apply a load. Now I need to try something. Go to step and let's try. Sorry, not here. Load here. I need to try something. Go to step and let's try to apply a pressure. A pressure. Gonna apply pressure. Let's try and then apply pressure. You apply it here, and that pressure is 1.5 Newton per millimeter square. So it's 1.5 Newton per millimeter square. Let's try this. Then okay. Oh, sorry, it's opposite direction. It's down. Okay. And I need to run it to try something. So let's apply. When you create, make sure you choose the second beam. So it's 2D. Not the model 1. Model 1 is that beam element. This is model 2. Then you continue. Okay. And you submit. Yeah, it's not assigned. So you go into material. You click here. You're not assigned. So that's why you create here. You click here. Then done. And you not assigned. So let's do it again. So I think after material, you need to do section property manager. So create here. You need to use not beam. It's now it's a solid indeed because it's not. It's not beam element. It's a solid element. Continue and assume its thickness is 100 at the width because you are drawing indeed the other direction. The thickness in the other direction. So the whole beam is 2D and the thickness the other direction. Then okay. And then you click here. You click onto section manager and then create. Click on that and then send okay. Save that. Go to your job right now and you submit. Want to try something here. Remember that was 0.04 millimeter and the dimension, the deflection. So let's see if they've got the same deflection value. You got results. You click on the results. That's the deflection value. And then you go to U. And it looks to me not the right deflection. So click here. Distance node 3.8. 3.8. Why? I think we've got the problem. I think incorrect applied load. This is pressure. So we need to look here. The pressure is 15 kilonewton per meter square. So 15 kilonewton meter square. That equivalent to, let's go to 15 kilonewton. Convert kilonewton. 15 kilonewton square to meter square, Newton millimeter square. So let's go this way. So it's 15 converted is 0.015. So this is 0.015. So that's basically 0.015 Newton millimeter square. Okay, 0.015. So okay, now you run it. Because you're applying a pressure, so when convert into units. Let's the results. Okay, look the deflection. It's very similar. If you go to node pop value, it's in y direction. It's similar to 0. Yeah, it's very similar to the beam element value. Very similar. 0.04, I mean 0.041. Very similar value. Anyway, now that you've done in 2D, and what you need to do is you need to create a third model, but in this case you want to do a 3D beam. To create a 3D beam, you go create model 3 part, and then you create a part. Now you use a 3D beam, part 1, and it's a solid, and you do extrusion. I'll tell you why. Then you continue. Let's draw firstly the cross section of this model, the cross section area. Here, the cross section was 200 by 200. So basically, click here, 0, 0. And then it's 100 by 200. That's cross section, 100 by 200. Then OK, and then done. Now ask you to extrude. So you're not going to extrude. The length of the beam is about 1000 millimeter. So extrude it 1000. So you've got extrusion. That's good. Now you go to property again. You create a material. You go material manager, and you go create, and then you elasticity, and then it's 70,000 and 0.3 Poisson ratio. Then you go to section manager, you go create, you go solid, homogeneous, you continue. There's no thickness, it's a 3D. So you keep it as it is, you don't put any thickness here. So you said okay. You click in the section manager, you go create, click here, and done. And then you said okay. So you create section. Now you go assembly, you go to assembly, you bring the beam, and you do independent mesh, and then okay. You go to step, you apply step here, you go create, and then initial step is general static, click it, and nonlinear, assume it, and apply incremental load. Then you do a mesh, you click here, assume you have a mesh of 25 millimeter size, you said apply, it looks fine, okay, and then you click on the mesh part, then you said okay, then you go to define the type of element, click here, and then don't use the reduced integration, you don't have to, it's enough. It should be a 3D stress, so don't use reduced integration. Then you said okay, and then you go into load, and then you need to have a fixed point here, so fixing here, so you click here and you create, assume this is initial, you click on that here, and you said continue, you click on the surface, and then you said done, and it's fixed on this part, so it is fixed. And then you said okay, and then you need to apply a pressure. Close this, you go here, you go create, you go into step, and then you apply a pressure, so continue, you apply a pressure on the top, then done, and it's 0 0.015. If you remember, it's 15 kilonewton per meter square. It's 0.015 Newton millimeter square. So I usually use everything Newton and millimeter, to be honest. It's easier to me. And done. So it's apply pressure, and then you can save it, and then you can go job, create, and he call it 3D, and ensure you are picking up the model 3, then continue, then OK, and submit it, and see how the deflection happening along the beam. So that's done, and then results, and then you click here. So it gives you the stresses. If you want deflection, you go to U in the Y direction. So you can click on here, node, prop value, and then you can define the deflection, which is about similar to what we've got before. Now there's something that's we done. Now if you really want to know the deflection on the beam along, so what we can do, go for example, give you an example. I want to model 2, for example. Let's say click, double click, and here you go to model 2. Okay, the go shop, and that is your 2D. So if you click here and you want to know really the deflection along, you see the deflection here, that deflection in Y direction along all the lines here. There's a way to do it actually. Let's look at it. You create a path along the way here. So what we can do, go to create, let's try it now. Go to Tool, Path, Manager. Okay, and then create. I think let's try continue. And after, let's try this. So click here, and then you click on Shift, and then click on every point over here. 1.1. I know it's gonna be a lot of work, but you can do. You want to find the deflection all over this point. Done. Then you said, okay, that is a path. So then you go to Tool, XY data, and then Manager, and then Create, and then Path, and Continue. Then that is a path being created. And then you go which frame, it's a last frame, of course. And you want what field output you want it. You want U2, which is a deflection in the Y direction. And then you set save as, and then it's okay. If you double click, you will find the coordinate versus deflection. Think, yeah. So if you plot it, it show you coordinate versus deflection. How much being deflected with the coordinate. But looks to me actually, maybe click here. If we start actually from different place, so go manager, create another path, continue, add after. So start from the support, maybe easier. Click one by one to show you the deflected shape and the value. And you can export it to Excel. And then you are done. So you've got Okay, and the path 2. This is the path 2. Start from 0 here. And you can go create, XY data manager. Let's delete this actually, you don't need it. Then you create, and then you go to path, then continue. Go path 2, be careful, not path 1, path 2. And the same thing, you need to U1 and save as, and then okay, and then if you double click, you can find here the coordinate. I think there's a way. It's not a coordinate actually. Let's delete this. I'll tell you why. If you choose not true distance, say x distance, maybe it's easier, better. X distance, because this is the next direction. Because it's gonna be deflected shape whenever. Okay, so yeah, here we go. Oh, doesn't do it. Let's see. Okay. X distance. Ah, x coordinate. Sorry, x coordinate. It's better to have an x coordinate. Then done. Double click. Here you go. Why it doesn't do it? It should give it to me. X coordinate. Okay, cancel. Let's do create path again. X coordinate. Or some here. Because it's path 2. Sorry, path 2. And then X coordinate path 2, and then save as, and okay. And double click. Yeah. Oh, it doesn't give. I don't know what's happened. It's carrying on an error for some reason. Have a look. X distance. Maybe distance. Save as. I don't know. That's weird. True distance. No, not true distance. Save as. Very strange. Maybe that's the distance. Maybe because I don't. I think so. Because I didn't mesh it in the way I wanted. So whenever. So these are here, and you can copy it Excel in Excel actually. Distance versus deflection. Distance. Okay, and then you can actually in Excel do like. So this is the beam deflected like this. See? Deflected beam. Start from 0 and to a length of whenever. Okay? You can do the same procedure actually for anything actually. The same procedure you can do it for example, for 3D. Want to go to 3D results, and you can do the same thing if you want to do on the line here for the one. Anyway. Okay, great. Okay, thank you very much. I think that's all for this tutorial, and follow me for more tutorials. Thank you.